A simple statement or block statement can be executed a controlled number of times using loop statements. A while statement is a loop statement that utilizes a boolean expression or a series of boolean expressions to determine if a simple statement or block statement is executed. The while statement can be broken down into three components. First is the reserved word while that begins the statement. Then the condition to be evaluated, and finally the simple statement or block statement that will execute if and only if the condition evaluates to true. Since the while statement is a loop statement, each time the simple statement or block statement is executed, the condition is re-evaluated. The simple statement or block statement will be executed as long as the condition evaluates to true. Here is a basic example of a loop that will print the numbers 0 through 9 to the console. As you can see, it uses a while loop. To begin the program, a variable of type int is initialized to 0. Next, we begin a while statement with the reserved word while, and then within parentheses is a boolean expression that will check if the variable count we initialized is less than 10. And if it is, the block statement here will be executed. Now within the block statement is a print line statement that will print the value of the variable count to the console. After that, we use the increment operator on the count variable to increment it by 1. So this block statement will run a total of 10 times based on this condition and the fact that eventually the variable count will no longer be less than 10. Let's use the debugger to take a closer look at what is happening when we run this program. Make sure you have this window open here. If you do not, look for these icons on the right of the screen and click any of the three here. If you hover over them, they say variables, breakpoints, and expressions. Now that is open, if it is floating, you can click the button here that looks like two windows stacked. If you hover over it, it says restore. That'll pin it to the side. Okay, so let's set a breakpoint here. That breakpoint will cause the program to pause once we run it. Notice if we click breakpoints over here, we see that breakpoint we just set. This comes in handy when you have hundreds or thousands of lines of code. Now let's run this program in debug mode by clicking this little green bug here at the top. If you get this red message here, go ahead and disregard it. In fact, go ahead and click at the end of it and hit enter. The only purpose of this is so that whatever prints to the console when we run our program is on a new line. Alright, now go ahead and click the tab here that says variables. Now notice there is one variable listed here. It is the variable args here that is included when we include the main method stub. We have not covered the purpose of this yet, but we will in a future video. Now notice we do not see the variable count on this list. That is because we set a breakpoint on the line where this variable is initialized. Our program has paused at this line and it will not execute until we instruct the debugger to execute it. And we could do that by pressing this button up here. If we hover over it, it says step over, which can also be triggered by hitting F6 on the keyboard. Now notice what happens when we do that. Now our variable list over here contains the variable count. And notice that the variable count has a value of 0, just as we initialized it. Also notice the next line of code has been highlighted, as well as the arrow here moving down with the highlighting. So the execution of this line of code involves the condition count less than 10 being evaluated. And right now the variable count has a value of 0, so this condition evaluates to true. Pressing F6 to step to the next line of code, we see because the expression evaluated to true, the block statement is entered. And the first statement within the block statement is highlighted and pointed to by this arrow. Pressing F6 again, we can see the print line statement prints the value of the variable count to the console. And using F6 to step again, we can see the variable count has been incremented to 1. Also notice which line of code is highlighted and being pointed to. The flow of the program has returned to the condition, and once again the condition will be evaluated. Notice we step through the block statement again since the variable count is still less than 10, with it now being 1. And also once again the variable count is incremented by 1, followed by the condition being reevaluated. And we continue to step through the program. Eventually the variable count is incremented to 10. And after it is incremented to 10, the condition is reevaluated. At this point the condition no longer evaluates to true, as 10 is not less than 10. Therefore, the block statement will no longer execute and we will step to the end of the program, as this program contains no other lines of code. Now at this point in the tutorial series, we have enough knowledge to build useful programs. To practice what you have learned, try to build a program that calculates GPA by prompting a user to input a letter grade one at a time using the scanner class. Allow for the input of Q, which will signal the user is done entering grades and would like their GPA to be calculated and displayed to the console. Do not worry about bad input at this point, meaning if the user inputs a lowercase a or a string of text or a number instead of specifically a capital A, B, C, D, F, or Q, obviously the program will not know what to do as we did not tell it what to do in these cases. That means when the program is ran, we will have to ensure that user input is explicitly limited to capital A, capital B, capital C, capital D, capital F, or capital Q. The solution to this exercise will be in the next video.